Good morning. So today we're going to look at how we can use the second derivative test to help us find our relative minimums and maximums. So we used this function yesterday and we went through and we found, whether it was concave up, concave down, our points of inflection. Today I want to take the same function and look at how we could use this function and the second derivative test to figure out what our max and mins are without using the first derivative test. So it's just an alternative to what we've already done, but we're going to try it anyway. So first of all, we went through yesterday and we found our first derivative and our second derivative, and I'm just going to write those down again, just in case, we need to have them a little bit more accessible. So that's our first derivative. And then our second derivative. So all of these have different, powers, so to speak, different things that we can do with them. So to use the second derivative test, we have to find those critical values still. Okay, so we're going to find the critical numbers, and we do that with the first derivative. So the first thing I'm going to do is I'm going to find the critical numbers. And this is what we've been doing for a while. We set f prime of x, so the first derivative, equal to 0 and solve. So if I set the first derivative of x equal to 0 and solve, I'm going to get negative 15 x to the fourth plus 15x squared equals 0. Now, if I solve that for x, I would have to factor out. I'm going to divide by, let's say, negative 15 first. Okay, so I would get x to the fourth minus x squared equals 0. Sorry about the bells. We are teaching George to use them when he needs to go outside, so I had to go take a quick break and take him out. But I'm back, so let's go ahead and finish this. So to solve for x, I'm going to factor out an x squared, leaving me with x squared minus 1 equals 0, and then find my critical numbers. Get 0, plus or minus 1. Okay, so those are my critical numbers. Now, the second derivative test. So if we look back up at what the second derivative test says to do, it says to take f prime of c and see if you end up f double prime of c and see if you get a positive or a negative number. If you do, then that would be a relative min or relative max. Versus what we've done in the past, which is break up into intervals and test a number in each interval. This allows us to just test the critical numbers. Okay, now the only possibility where you'll have to just go to the first derivative test would be if you get that the second derivative is exactly 0. In that case, you just have to use the first derivative, and we'll have to test values on either side of that critical number. So let's look at our three critical numbers, okay? So we have 0, negative 1, and 1. So I'm going to use a table that's similar to what we've done before. We have our critical number. We have what happens when we plug it in to the second derivative. We'll say f of c, so we'll call our critical number c, f of c, and then we'll make some conclusion. And then we need to know what the point is, right? Because that's what our minimum or maximum is. It's the actual point. So let's go ahead and fill in our table. My lines are terrible this morning. All right, so first critical number, so we have negative 1, we have 0, and we have 1. So let's see what happens. So if I plug in f of negative 1, now f double prime of negative 1, sorry, because we're looking at what happens with the sign at the second derivative. It might help if we have our second derivative written here so I can see it too. And it was, if we go back and look, it was what, negative 60x cubed plus 30x. So we're plugging into that function. Now, I've talked about how we can use our calculator to do this pretty easily. just to do the test, but we could plug it in, right? We could do -1 cubed is going to be -1 times -60 would be +60, and then plus 30 minus plus 30 times -1 will actually be -30. So that ends up being 30, and that's a positive number. So what we can conclude about that is that this would be, since it's a positive number, okay, that's the key, this is going to be a relative minimum. So that's our conclusion. And then we'd want to find the point. So essentially I want to know what happens when we do C, f of C. So -1, comma, whatever we get when we plug it into our original function, which if you do that, and I know you guys could do that, it would be -2. All right, let's go through 0. So f double prime of 0. If we plug that in, it's exactly 0. Now this is an instance when the test fails, so I can't really make any conclusions. I'm going to have to use the first derivative test, and we'll do that in just a minute. And then I've got the last number to test, which is f of 1, and that will give us -60 plus 30, which is -30, and that's negative. And what I know from that is that this will be a relative maximum. And this is all going back to what our second derivative test says. Once again, I want to know what that point is. So that means, plug in f of c, so plug it back into the original function. So the original function gives us a 0.12 if we plug it in. So we know a couple of things. We know that there's a relative minimum at the point -1, -2, and we know there's a relative maximum at the point 1, 2. But I've got a question about what's happening around 0. So I'm going to have to go back to the first derivative test. So I'm going to use the first derivative test for our critical number 0. Now I have to keep in mind that this critical number is only one of 3 critical numbers. So when I set up my table, I have to remember I'm going only between -1 and 0 and 0 and 1 when I set up my table. So we set up our table, we say, what's the interval? So in this case, our intervals are, like I said, from -1 to 0. So we're only looking at what's happening around 0, right? So I don't need to worry about anything else. So from -1 to 0 and 0 to -1, those are our intervals. So we pick a test value. Maybe I pick -1/2 and +1/2. And then I see what's happening at f prime of c. So what's happening at that critical number? What's the sign? So this time it's f prime of c. All right, so f prime of c, and again, I'm just writing it here because we can't see it above. The first derivative of x was -15 x to the 4th plus 15x squared. So, use your calculator and figure out what's happening at -1/2, and then let's put that value in there. So if you remember from our first derivative test, our conclusion is our function increasing or decreasing? So since I got 2 positive values at numbers close to 0 on either side of 0, I know that it's increasing here and here. And if you remember, our maximums and minimums come from places where we have an increasing interval bumping up against a decreasing interval, and we don't have that happening here. So what that tells us is that there's no max or min at x equals 0. Okay, so the point there's irrelevant. It just doesn't matter. So my conclusion from this whole process, so from start to finish here, if we look at it, my conclusion that I can make is right here, that I've got a relative minimum at -1, -2, and a relative maximum at 1, 2. And then we compare that with a lot of the different things that we talked about yesterday, and we're beginning to know a little bit about that function. We looked at the graph of this yesterday. I'll put this back up. I'll put the graph on the screen again for us here so we can take a look at it. So if we look at the graph, putting everything together that we found yesterday, we figured out where our points of inflection were. They were, at some weird values, and we kind of said that's okay. But at least we could narrow down where those points of inflection were. And today we figured out where the relative mins and maxes were by using the second derivative test. And then we can also look at, what intervals are we talking about, concave up and concave down. So from like here on, this is concave down, or concave up, because that's where our point of inflection is. From here to here, we talked about it was concave down. And then from 0 to that other point of inflection, now we're back to concave up. And then from that point of inflection to our relative max, actually from that point of inflection and then forever, we are concave down. Okay, so I just kind of used the graph to sort of identify what those characteristics would look like on it. What we're getting to the point that we're going to be able to do starting hopefully tomorrow is be able to actually take a function and completely graph it from start to finish. If you feel like you're okay and you want to try to start working on some of the problems for tonight, they're going to ask you to find the relative mins and maximums using the second derivative test. If you're good, you can stop watching the video right now. If you'd like to see another example, you can continue watching and I'll do a second example. Okay, so here's our second example. I'm going to give you some prompts and I'm going to ask you to try to do these things on your own. So the first thing I want you to do is find the first derivative and then figure out your critical numbers. So pause the video here, find the first derivative, find the critical numbers, and then come back and check your work. Okay, so your first derivative, you should be able to see here. And then when you go to find your critical numbers, remember we look for when is the first derivative equal to 0, and there's only going to happen when x is 0. And then are there any places when the first derivative of f of x is undefined? And that would come from the denominator becoming 0. So in order for the denominator to be 0, this value has to be -1. Right? Because that's the only thing that when we add it to 1, we get 0. There's no way for this to be -1 because it's a number being squared. It's always going to be positive. So there's no place where f prime of x will be undefined. Okay, so we've got our critical numbers. All right, so next step is to find our second derivative. Let's do that next. So pause the video, find your second derivative, and come back. So the second derivative is considerably harder. I went through and used the quotient rule. Low, d high, minus high, this is the derivative of the low, over low, so the low function squared. And then I've kind of simplified it a little bit. I multiplied 1/2 x and 2x together just to get x squared, and then just left everything else alone. I simplified the denominator a little bit too. We'll multiply those exponents together to just get x squared plus 1 in the denominator. We've done a problem similar to this, but it's been a little while. So what I think is the best way to kind of approach this is we want to try and we can maybe get rid of all of the half powers in the numerator. So I multiplied the top and the bottom of the fraction by x squared plus 1 raised to the 1/2 power. And then when I distribute that, multiplying these two together is going to, add your exponents. 1/2 plus 1/2 is 1, so it's just x squared plus 1. And then multiplying this guy times this expression, when we add -1/2 and 1/2 together, we get 0. So this guy just ends up being 1 when we multiplying it, leaving it just with minus x squared. And then when we multiply these together, you have an exponent on this of just 1. So you add your exponents together, and 1 plus 1/2 is 3/2. So we end up with this expression here, x squared plus 1 minus x squared over x squared plus 1 raised to the 3/2 power. Subtract x squared and x squared, and this is your derivative. Okay, so from there, I'm going to make my table. All right, so let's go ahead and make the table. Okay, so I set up the table, or my chart, whatever you want to call it. I have my critical number. There's only one of them this time. And remember, our second derivative says you can just plug in the critical number right into the second derivative. And if you get a positive number, that means that you have a relative minimum at that critical number. If you have a negative number, you have a relative maximum at that critical number. So the sign of f double prime of 0, well, I have to plug in f double prime. I have to plug in 0. So I take f double prime of 0 is going to be 1 over 0 plus 1 raised to the 3/2 power, and that's just going to be 1. That's a positive number. So what that tells me, since it's positive, is that we have a relative minimum happening right there. Okay, so now I just need to figure out what that ordered pair is. So I'm going to plug in 0 into the original function. Remember, the original function was just the square root of x squared plus 1. So if I plug into the original function, I'm going to get 0 plus 1, which is just 1. So my answer to this problem, where are your relative mins and maximums? I just have a relative minimum at the point 0, 1. Okay. Now, is this any better or easier than doing the first derivative test and setting up the intervals? I don't know. You could probably argue it one way or the other. It's just an alternative approach. That's all. And since we're probably going to be doing some things with our second derivative anyway, it's probably going to end up being, in some cases, easier to figure out where your relative minimums and maximums are. All right. I'm going to create another video if you need it to maybe go over 1 or 2 problems from last night. But you will have an assignment for today. Go ahead and check, what is it called? Go Formative, and work through as many of those. I think there's 4 problems on there today. Okay, I will see you tomorrow, and we'll go over some questions from yesterday and today.